In this video, I'm gonna explain you what is BigO. It is essential that you understand BigO as a good programmer or when you go into technical interview. Okay, welcome. Now let me explain to you what is BigO all about. Okay, BigO is one of frequently asked in coding interviews like Google, Amazon, Netflix. Big tech companies ask you about this concept. You have to know as a good programmer also this concept. Now let me explain to you like this. Think like that. On the same balance there are two cores, core 1 and core 2. They say they are different algorithms. Okay, now they take or they solve the same task. Now I may say like core 1 is better than core 2 or core 2 is better than core 1. Okay, I have my own reason to say that. Okay, I will explain to you soon. So comparing these two cores in mathematically, it is all about BigO. Now think of like this. There are two cores, core 1 and core 2. When I try to compare and contrast these two cores using different condition, when I try to run my code 1 in my machine, when I try to run my first code in my machine to complete its tasks, it takes about 4 seconds. Okay, it takes about 4 seconds. Now when I run my second code, it takes about 50 seconds. Now the first code is better because it completed its tasks only in 4 seconds, but the code 2 is not good. Okay, to complete its tasks it takes about 50 seconds. Now this concept is come in time complexity. Okay, we don't measure time complexity in minute or second. We measure time complexity in number of operations. If you have Core i7 or dual computer, the number of operations is the same. Okay, now when I try to explain to you what is space complexity is, okay, this is also easy concept if you understand it. The space complexity is about which code is performance less memory on this machine. Okay, now the first code is run in good time. Okay, only takes 4 seconds. The code 2 is not good. Okay, it is takes about 50 seconds. Now when I look first code, it takes about 4 seconds, and the memory, the blue area is the memory consumption. It takes a lot of memory usage in my machine, so it takes a lot of memory, but the code is so fast. When I look second code, it takes about 50 seconds, but the memory usage or on my machine, it takes about a little bit. Okay, it takes a little amount of memory. So in terms of space complexity, code 2 is better. Now let me explain to you these three symbols and their uses. Okay, the first one is alpha, the second one is theta, the third one is omega, or commonly known as BigO. Okay, now these are concepts used in to describe what is the best case, average case, and the worst case. Okay, now let me show you as an example. Assume this is an array. Okay, and we are trying to find the number 1. Okay, using a for loop. Okay, now the first number. Okay, we are targeting to find the number 1. Okay, there are 7 elements in the array, so the first number 1 at index 0 is our best case. Okay, the number 7 is our worst case because it takes a lot of time, and the 4 number is average case. So the first number in array is called best case alpha, and the 4 is the average case called theta, and the worst case called BigO. Okay, there is no BigO average, BigO best. Okay, you have to just remember that BigO is all about the worst case. Now let me introduce you to order of n. What does this mean? So think in this graph. There are n represents number of operation, t represents for time. Okay, now when our number of operation increase, the time also increase, so this is called linear. Okay, this is called linear. Now this order of n, you have to analyze, or you have to know on the code, okay, about your big O representation. Now let me show you this order of n in ignore constant concept. Okay, now think this is your code, like finding a big value. Okay, this is a function, okay, and it takes n as parameter. Now what is my point is to show you how to know this code is order of n. Okay, now to know this order of n, the first loop, okay, the first loop is takes n times. Okay, it takes n times. Okay, when you look for loop, it takes n times operation. Now I create another for loop. Okay, I create another for loop. Remember here, this is not a nested loop, they are separate for loop. Okay, now I created a j loop. This is also take n operation time. Okay, n operation time. Now when I try to print them separately, okay, now when I try to print them separately, you have to remember that every loop, okay, every loop takes n times operation. Okay, now because it is linear, okay, because it is linear, when I call my function and take 3 or whatever number or 4 you add in that code, it takes a linear time. Okay, now the first loop 0 1 up to 3, and the second j loop 0 1 2 3. Now the point is to analyze how this order of n works. So you have to ignore the constant. Okay, so the first loop n plus the second loop n operation, which equals to 2i's of n. So we have to ignore the constant 2, number 2. So when we ignore the 2, n remain only. So this operation we call it order of n. We have to ignore the constant. Remember, we have to ignore the constant in different for loop condition. You have to know this concept. Remember, this is not nested loop, they are different loop, so every loop takes n time operation. So this is called order of n operation. Okay, so many students like computer science students, software engineering students have to analyze their code, which one is it is order of n or order of n square. You have to know this concept very well. Okay, now let me explain to you what is O of n square mean. In your time versus number of operation graph, the line look like this exponentially. Okay, order of n square. Now to understand this concept, okay, to understand what is big of n square, okay, in a previous video, like I told you, every for loop takes n times order of operation. Okay, it takes n times operation. Now let me explain to you in this nested loop. Okay, in previous video we created 2 different for loop. Now I am creating a nested for loop. Okay, they are different in when we try to analyze the code. Okay, they are different nested loop and separate each another for loop. Now I create first for loop I equals to 0 and I is less than n I plus plus increment. Okay, in every iteration. Now this first loop takes n operation, like I told you before, and another nested loop. Okay, another nested loop for let j equals to 0, j is less than n, j plus plus. This is also takes n operation. Okay, now when I try to console out or print out these 2 for loops, they are nested. Okay, so in a previous video we are we sum up. Okay, we add this n plus n, we say twice of n, we ignore the constant 2, and we say order of n. Now this is different. So in nested loop we multiply, not add. Okay, we multiply this nested loop. Before we go to order of n square, let me show you what this nested loop do. Okay, it prints 0 0 0 1 up to 9 9. Okay, up to 9 9 they display nested. Okay, nested loop numbers. So the point of this code is to show you n square order of, okay, n square order. You have to multiply every operation, okay? If it is nested, you have to multiply. If they are different for loop, you have to sum up, okay? Now in this for loop I multiply them, okay? In this for loop, n times n, or the first loop in times the nested another for loop, okay? They work together, they are not different for loop, they work together. So we have to multiply n times n, it is n square, okay? And it's become order of n square. Now what if this nested loop become nested loop, 3 for loops inside, okay? What if there are 3 nested loop? Now let me say the third nested loop, let k equals to 0 and k is less than n, okay? This is also takes n times of operation. Now we multiply them, n times n times n, okay, which becomes n cube. But no matter what we add in this nested loop, it is always that it is order of n square. We don't say order of n cube, n 4, n 5, okay? Whatever the number, we don't say like that, okay? Now let me show you what this for loop do, okay? Now it takes as a 3 numbers, okay, like 0 0 0 0 0 1 up to 9 9 9, okay? This is a 3 nested loop, nested for loop. So every loop takes n times n times n, it's become n cube, okay? It becomes n cube. But we don't say like n the power of 4 and the power of 5 and the power of 6. We say n square, or big O of n square, okay? So you have to remember this concept to understand easily. Like I told you, remember the rule, okay? If the loops are nested, they are n square. If the loops are different, for loop, they become, we ignore the constants and they become order of n. So now when we show our code, it looks like this, okay? N times n times n, they become n the power of 3, okay? Now we ignore the first okay, the first or the other numbers, and it becomes n square. Now let me show you some tricky concepts in BigO, okay? Now I explained in your previous video, okay? As example, let me show you again. There are 2 for loops. You may say the first loop takes n operation, okay, and the second for loop takes n operation. Now when we sum up these 2 n, okay, when we sum up these 2 n, it's become order of 2n. So we ignore the 2 and it's become order of n operation, and it is a linear. Now what if your code look like this? The function takes 2 parameters, a and b, okay? What if your function looks like this? You don't say order of n or n plus n, it becomes twice of n. No, it becomes order of n. It is wrong, okay? You don't have to say like that. You have to recognize the parameters, okay? You have to say that the first loop takes a parameter a, yeah? So order of a plus order of b, it becomes order of a plus b. It is the answer. Now let me explain to you non-dominance concept. This is also a tricky question, okay? You have to know this concept. Now this code, what it do is there is a nested loop, okay? It takes order of n square operation, like explained in the previous concepts, okay? And there is other single for loop, okay? Now we have to drop the other for loop as when we analyze this BigO operation, okay? We have to drop non-dominance, okay? We don't say like this is order of n square plus n, okay? We have to drop or ignore the other for loop or the other operation. You have to know this is very important and tricky question, okay? This code become order of n square. If you face like this kind of problem, okay, you have to say order of n square. Now let me show you big of 1 notation. Okay, you have to know these concepts like big of order of n and big of order of n square. Now this is it takes only one operation. Okay, one operation, that is addition. It may be subtraction. In this case the function is it takes only one operation, that is addition, so it is a constant. Okay, 1 plus 1 1, 1 million plus 1 million it is 2 million. Cool. So that is big of order of 1 constant, this blue line. Okay, greens and yellows are exponential and linear. Okay, so this is excellence of big of notation. Now let me explain to you what is order of logarithm of n meaning. Okay, this is easy concept, you have to understand it. Now think this is a sorted array. Now I am trying to find number 1, okay, as a target. Now I use a divide and conquer method to find number 1. Okay, I will cut it in the half. Okay, now the number 1 element is found in the left, so I ignore the right side of the array. Okay, my point is to find the number 1, so I will ignore the right part of the array. Now I have 4 elements. Okay, now again my target is 1, I will cut it in the half and I will ignore the right side of the array. I have 2 arrays now. Okay, now I will cut it in the half. Now I get my number 1 value. Now let me explain to you how this answer is come. Log of 2 the power of 8, which is equals to 3. In previous explanation divide and conquer video, we are trying to find number 1 using divide and conquer method. Now we divide that array 3 times. Okay, we go 3 steps, so that number 3 is our step. Okay, how many times we cut that array? Okay, the steps are 3 times. Okay, now 2 the power of 3 is 8 in exponential rule. Okay, now the 8 represents number of elements in the array. Okay, the number 8 represents number of elements in the array, so we have 8 elements. So we say log of to the power of 8, which is equals to 3, or number of the steps is 3. So you have to understand it like this way. Now let me summarize on this graph all big O notations. Okay, in this graph the red represents, let's say, it is horrible, and the orange represents bad, the yellow fair, the lemon parts represents a good. Okay, and the dark green represents excellent. Now this orange big O notation represents order of n log of n. The green lemon area represents also order of log of n. Okay, and the green area is constant, like we studied in the previous video. Okay, so if you look that red area, there are quadratic, exponential. These are also bad big O notation.